Have you ever stopped to think about what's happening right under your feet? There's this vast, hidden network of pipes, kind of like the arteries of our world, that makes modern life possible. Well, today, we're diving into an unseen revolution that's happening down there, all thanks to one remarkable material. So let's start with a big question. Why are those city arteries failing us? I mean, for decades, we've built our world on a foundation of pretty traditional materials. But that foundation, well, it's cracking, it's rusting, and it's really starting to show its age. The consequences are just getting too big to ignore.
For the better part of a century, we've really leaned on two main players, steel and concrete. And look, they did their job. But steel, well, we all know what happens to steel. It rusts, it corrodes, and it's incredibly heavy. And concrete? It's cheap, sure, but it's brittle, and it just doesn't hold up well against chemicals. The reality is, these materials are from another era, and they're just not built for the world we live in today.
So, if the old guard is on its way out, what's next? The answer isn't just one single new material. It's about combining materials to get the best of all worlds. And that brings us to the hero of our story, GRP, a composite solution that was literally engineered to solve the problems of the past.
GRP. It stands for glass reinforced plastic. And honestly, that name tells you pretty much everything you need to know. It's not just one thing, it's a composite. It's a team-up between super strong, hair-thin glass fibers and a tough protective polymer resin. It's this combination that creates something special, a pipe that's incredibly strong but also surprisingly light.
The real magic is how these pieces work together. The glass fibers, think of them like the steel rebar inside a concrete pillar. They provide all the raw strength. And you can even get specialized versions, like ECR glass, which gives you 20% more corrosion resistance. Then you've got the resin. That's the concrete part of the analogy, holding everything together and protecting the fibers from chemicals. And finally, you have the additives, kind of like the secret sauce. Things like UV stabilizers that can literally double a pipe's lifespan.
Okay, so the material itself is brilliant, but that's only half the story. How these pipes are made is just as crucial. The manufacturing process isn't just about getting the right shape, it's about engineering specific superpowers into the pipe, whether that's handling insane pressures or keeping our drinking water pure.
There are basically 4 main ways to do it, and each one is unique. Filament winding is the most popular. Just picture weaving a super strong cocoon of glass fibers around a mold. Centrifugal casting uses G-forces to forge a perfectly smooth, dense inner wall. Pultrusion is all about creating very specific, continuous shapes by pulling the fibers through a mold. And then there's hand layup, which is more of an artisanal approach for creating really complex, custom parts.
And this is where it gets really smart. The method is always matched to the mission. You'd use filament winding for a high-pressure oil line because you can angle those fibers perfectly to handle the stress. But for drinking water, you'd go with centrifugal casting to get that ultra-smooth surface for maximum flow. It's all about using the right tool for the job.
So we know what it is, we know how it's made. Now for the bottom line. Why is it actually better? Well, the advantages here aren't just small improvements. They're a total game changer. And the data? Well, the data speaks for itself.
Just look at this. The strength-to-weight ratio for GRP can be more than double that of steel. What that means in the real world is you get something that's way stronger, but also way, way lighter. And that translates directly into huge savings on a project. You don't need giant cranes and huge crews to install it, which cuts down time and, more importantly, cost. And here's the knockout punch. GRP is naturally immune to corrosion. Unlike steel pipes that need expensive coatings and constant monitoring to keep from rusting away, GRP just doesn't care. You can bury it in the nastiest soil or pump chemicals through it, and it holds up. That means way less maintenance and far fewer failures. And that natural immunity leads to this incredible number, a potential lifespan of over 100 years. Seriously, think about that. Your typical steel or concrete pipe might give you 20, maybe 50 years if you're lucky. GRP is designed to outlast the people who install it. That completely changes the long-term economics of any project. And on top of everything else, these pipes are just plain tough. They can operate in freezing Arctic conditions all the way up to the blistering heat of an industrial plant. These are environments where traditional materials would just give up and fail. The resilience is just amazing.
All right, so the technology sounds fantastic on paper, but where is it actually being put to the test? Let's take a look at how GRP is already making a huge impact out in the real world, right now. It's probably closer than you think. In our own towns and cities, GRP is fast becoming the #1 choice for critical water infrastructure. For drinking water, that smooth, non-corroding surface means cleaner water and less energy to pump it. And for wastewater, it handles that corrosive environment with ease, preventing leaks that could pollute the ground.
Now, in the industrial world, things get even more intense, and this is where those specialized resins come into play. In chemical plants, you'll find GRV pipes. That's with a vinyl ester resin that can handle incredibly aggressive acids. For oil and gas, you'll see GRE pipes using an epoxy resin that can take on extreme pressures and temperatures without even flinching.
So what about one of the most hostile environments on the planet, the ocean? GRP is a perfect fit here. It's totally immune to saltwater corrosion, and its lightweight is a massive advantage on an offshore platform where every single pound counts. You'll find it everywhere, from desalination plants to the ballast systems inside massive ships.
When you put all the pieces together, it becomes clear this isn't just about finding a better pipe, it's about building a better tomorrow. The case for GRP is about making smarter choices, both for our wallets and for the planet.
Let's talk money, because the savings are real and they come from everywhere. The biggest chunk, by far, comes from lower installation and transport costs, just because it's so much lighter. Then you factor in the near-zero maintenance costs and a lifespan that's 2 or 3 times longer, and the financial argument is just undeniable.
But it's not just about the money. It's actually a greener choice. The manufacturing process uses less energy than making steel, which means a lower carbon footprint. The leak-proof design means we save precious water and prevent contamination. And yes, it's even recyclable. It just ticks all the boxes for a more sustainable future.
And this isn't some niche, futuristic technology. The market for GRP pipes is growing steadily, year after year. It's absolutely on track to become the new global standard for any modern, sustainable infrastructure project. The revolution is happening right now.
So in the end, we've taken something as basic, as fundamental as a pipe, and completely reimagined it using modern science. And it really makes you wonder, if we can radically improve this one hidden piece of our world, what other unseen foundations are next? What we'll build next?